My name's Dr. Adrian Brown and I'm a specialist dietitian. And I'm here today to see if fruit really is as bad as sugar. Now there's a lot of confusion and misinformation currently on the internet about how dangerous sugar really is. Whether in the form of table sugar, of fruit sugar, and also sugar broken down from starchy food. It really makes you wonder, is fruit really that dangerous? Or can you actually eat it? Much of the conversations had on the internet at the present time regarding fruit are from people with no formal training in nutrition. They've had a great personal experience following a very restrictive diet, are ends of one if you please, and then preach to everyone that they should follow the same diet and restrict all fruit with no hard scientific evidence to back up their opinion. One particular issue that I have at the present time is the use of infographics that show fruit or foods containing starch and comparing them with the equivalent amount of sugar, usually in the form of teaspoons. These infographics, in my opinion, are dangerous, misinformed, massively oversimplify a very complex topic, and finally, they present a risk of causing the general public to unnecessarily restrict fruit, which in my opinion, as a registered dietitian, is actually of great concern. Rather than bore you with all the science, because let's be honest, who wants to see that? I want to show you what happens to my blood glucose after consuming fruit and directly comparing it with sugar. Let's find out, is fruit really that bad? How, you ask? I'm going to eat the suggested portion size of the following fruits shown on the infographic and compare that with the suggested teaspoons of sugar. I'm going to wear a continuous glucose monitor, which is a special monitor that measures my blood glucose every 5 minutes. So we can accurately measure the response of my post-meal blood glucose after eating either the fruit or the sugar. So, in a fasted state, I'm going to firstly have 6 teaspoons of sugar, which is the equivalent of 24 grams of table sugar. Chemically, this represents an equal split between glucose and fructose. Then I'm going to consume 223 grams of apple. And as you'll see, that is actually quite a lot of apple, which is mainly made up of fructose. After which I'm going to consume 1 large apple to show you if there's a difference. And finally, I'm going to eat 150 grams of grapes, which is predominantly made out of glucose and fructose. After this, I'll download my data and I'm going to have it independently analysed by a statistician to avoid any bias that I might have, and statistically show you if there's a difference in my blood glucose reaction compared to having fruit with the equivalent amount of sugar. My narrative here is let the evidence do the talking instead of the dogma, scaremongering and mistruths. What we have here is one of the infographics that I described earlier on, which reports showing sugar in fruit. As you can see, on the left-hand side, there's a piece of fruit juice, and a chocolate bar. And on the right-hand side are the suggested teaspoons of sugar. This is a very simplistic, reductionist point of view, which on the surface seems like an educational tool, but when you look closer, represents a confusing message. When shown to individuals with no nutritional knowledge, not only do they feel they shouldn't have fruit, but they also feel that they would prefer to have a chocolate bar instead of an apple, which clearly is not the intention of this infographic. What you can see here is 150 grams of grapes, 223 grams of apple, and the 24 grams of sugar. Now, here's what you've all been waiting for, the data. As the fasting blood glucose were different, instead of using total area under the curve, we're going to use incremental, which allows us to look at both positive and negative effects of the sugar and fruit on my after meal blood glucose. The first graph that you see here is a time course change in blood glucose from baseline over 120 minutes. As you can see, they react very differently to each other. What you probably notice first is that there's a large spike with the sugar within the first 30 minutes, a lesser spike for the 150 grams of grapes, and a delayed one for the 223 grams of apple. And then the single apple hardly affects my blood glucose at all. The second graph is slightly different. What we've done is take all the readings above baseline fasting glucose to show you how each one positively increases my blood glucose over the full 120 minutes. What you see here is that sugar has a much larger positive effect on my blood glucose compared to the 150 grams of grapes, 223 grams of apple and single apple. Furthermore, when this was analysed, there's a statistically significantly greater positive response from the sugar when compared with all the fruit, which means in simple terms that the results that we present here are unlikely to have happened due to chance and that there's actually a real difference. This therefore demonstrates clearly that comparing teaspoons of sugar with fruit is simply not helpful and in fact wrong. To make this simpler to understand, sugar increases blood glucose above baseline 2 times more than grapes, 10 times more than 223 grams of apple, and a whopping 138 times more than the single apple. Now you tell me that teaspoons of sugar are the same as having a piece of fruit. So, here we are at the end. And as you've seen, when directly comparing sugar and fruit, there's only one winner. It's clear that using teaspoons of sugar to represent fruit is an oversimplification and should be avoided where possible. I therefore ask individuals that are using such infographics to have disclaimers and caveats on them that say that this is not a good representation of post-meal blood glucose in those with normal glucose tolerance. I appreciate there are some people out there that have had amazing transformations restricting carbohydrates, fruit and added sugar. The main mechanism of this, however, is energy restriction and the ensuing weight loss, and not the miracle of avoiding one particular macronutrient. Obviously, I have to say there's a couple of caveats to this. Firstly, I don't have type 2 diabetes. I have good blood glucose control. And therefore, I cannot infer that this patient population will have the same blood glucose response as I have. Secondly, I've attempted to remove as many confounders as possible. I therefore did this after a 10-hour fast. I did it at the same time. In addition to that, I attempted to have a standardized meal in the evening. But this doesn't mean that there aren't confounding variables that might have affected the result. This wasn't a controlled ward study. However, rather it was a representation that this type of oversimplification is simply not helpful. And this really comes down to the point of why I did this in the first place. What I want to have good information out there, good evidence-based information, rather than people using dogma and misinformation to scare people to avoid fruit. Now, if you found that this has been helpful, what I suggest is you share it, because there might be other people that also are dazed and confused whether they can have fruit. If you'd like to find out a little bit more about me and follow me, I'm on Twitter at BrownAD, that's BROWNADEY, and I look forward to seeing you there. Now, you ask, after all that hard work, what am I going to do? You know what I'm going to do? I'm going to go and have some fruit.